Hello. In today's lesson, we will look at some direct current circuits. To begin with, we will look at resistors connected in series. You remember we talked about capacitors in series. Now, how are electrical components connected in series? When they are connected end to end in a closed path. So how are resistors connected in series? Resistors can be combined suitably to produce either a larger value than the ones you have or a smaller value than the ones you have. Now, it can be a series combination or a parallel combination. A series combination or a series connection is an end-to-end connection like this. You have resistor 1 of resistance R1, resistor R2 of resistance R2, and resistor R3 of resistance R3. Look at the way they are connected in series. They are connected from end to end, and the combination is connected to a source of potential. Now, what can be a source of potential? An electric cell is a source of potential. So you can connect the combination to an electric cell. We will now see what happens or what will be the total resistance when we connect resistors like this. So three resistors R1, R2 and R3 are connected in series and connected across a source of potential. Now tell me, what is the total potential drop across the combination? The total potential drop across the combination is V. What does that mean? What is the meaning that the total potential difference is V? It means in order to drive one coulomb of charge from one end to the other, you need to do V joules of work. That's the meaning there. So V joules of work is done to transport one coulomb of charge across R1, and then across R2, and then across R3. That means the total work done is now divided among R1, R2 and R3. So, when resistors are in series, what happens to the total potential? The total potential is divided as V1 across R1, V2 across R2, V3 across R3 in such a way that the total potential V equal to V1 plus V2 plus V3. Alright, let's see. Three resistors R1, R2, R3 connected in series and connected to a source of potential V. V is the total potential drop across the three resistors. Now, suppose V1 is the potential drop across the resistor R1 and V2 is the potential difference across R2 and V3 the potential difference across R3. Then we can say V equal to V1 plus V2 plus V3. I hope that is clear, because V is the total work done to move a unit charge from the left end to the right. That means across each of the resistors. So the total work done is the work done to move it across R1, that is V1, plus the work done to move it across R2, and that is V2, plus the work done to move it across R3, that is V3. So V equal to V1 plus V2 plus V3. But if a current I is driven from the cell, that current I will flow through R1, R2 and R3 without any change. each of the resistors will have the same current flowing in it, and that will be the total current. Is that right? Right. But the current in each of the resistors is the same, which is the same as the total current. So what do? We have the equation V equal to V1 plus V2 plus V3. If you now divide this equation by I, that is common to all those resistors, what do you get? V divided by I equal to V1 divided by I plus V2 divided by I plus V3 divided by I. Alright, can you recall Ohm's law? What is V divided by I? Ohm's law gives us V equal to Ri. Therefore, V divided by I equal to R. V divided by I equal to R, which is the total resistance. Because V is the total potential, I is the total current. Therefore, V over I is the total resistance. What is V1 over I? V1 over I is the resistance R1. V2 over I is the resistance R2. And V3 over I is the resistance R3. Therefore, we have R equal to R1 plus R2 plus R3. So when do we connect resistors in series? When we need a greater resistance than the ones we have. Let's do a simple problem. What is the resistance of a series combination of 4 2-ohm resistances? If you have 4 2-ohm resistors and you connect them in series, what will be the total resistance? Well, the total resistance will be the sum of the resistors. R equal to R1 plus, R2 plus, R3 plus, R4, and that will be 8 ohm. Let's now look at resistors in parallel. How do we connect a number of resistors in parallel? What is the meaning of a parallel connection? If you remember what we did in the case of the capacitor. If I have 2 resistors, now suppose these are the 2 resistors. This is one resistor, this is the other resistor. How do I connect them in parallel? What do I need to do is connect the 2 ends of the 2 resistors together and connect these 2 ends together, and then the system is connected to a cell or a source of potential. Well, when each resistor is connected across the same 2 points, that means if you have a number of resistors and each is connected across the same 2 points, then we have a parallel connection. Now here I have resistor R1, resistor R2 and resistor R3. Notice that R1 is connected between A and B. R2 is connected between A and B. R3 also is connected between A and B. So these 3 resistors are now in parallel. I hope now you understand the difference between a parallel connection and a series connection. So 3 resistors R1, R2, R3 are connected across 2 points A and B, and the points A and B are connected to a source of potential V. That means the potential difference between the points A and B is now V. Tell me, if V is the potential difference between A and B, what is the potential difference across the resistor R1? The resistor R1 is connected between A and B. So the potential difference between A and B will be the same as the potential difference between the ends of the resistor R1. Similarly, the potential difference across R2 will also be the same as the potential difference between A and B, because R2 also is connected between A and B. So, this means that the potential difference across R1 equal to the potential difference across R2 equal to the potential difference across R3 equal to the total potential V. So, one important result you must remember: when resistors are connected in parallel, all of them will have the same potential difference across them, and that will be equal to the total potential. Whereas, when resistors are connected in series, the total potential is divided into the individual resistors. Alright. Now the total current, what happens to the current but? If I is the total current, tell me what happens to the total current when it comes to the position A. When it comes to A, it finds there are three paths that it can go. So a part of the total current will go through R1, another part will go through R2, a third part will go through R3, and when they all reach B, they will all combine to become the same old current I. That means if I1 is the current going through R1, and I2 is the current through R2, I3 is the current through R3, then I equal to I1 plus I2 plus I3. There you are. So the total current is divided in a parallel connection, but the total potential remains the same. So what do? Since the potential is going to be the same for all, we are going to divide this equation by V. What do we get? I divided by V equal to I1 divided by V plus I2 divided by V plus I3 divided by V. Well, I is the total current, V is the total potential. Therefore, what does I over V represent? If you remember, V over I is the resistance R. Therefore, I over V is 1 over the total resistance. So, if R is the total resistance, then 1 over R, I over V equal to 1 over R. I1 over V is 1 over R1. I2 over V is 1 over R2. And I3 over V is 1 over R3. So, if three resistors are connected in parallel, the total resistance R of the combination is given by 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, don't confuse this with the capacitors, because when capacitors are connected in series, the total capacitance is 1 over C equal to 1 over C1 plus 1 over C2 plus 1 over C3. Now the case is exactly opposite for resistors, so take note of that. Resistors are connected in